All right, so I'm going to do, this is 15.3. So we're going to find the least common denominator, and then we're going to write rational expressions with the least common denominator. And so I'm going to skip this one here. I'll go to this one. So in this case here, when you're looking for the least common denominator, what you want to do is you want to see what each one of them has in order for them to get the same thing. So you have to have exactly the same denominator. So then what happens is for this one, oops, sorry, that should have been red. For this one, I'm going to give it a 3 because this one already has a 3. Now this one has x to the 5th power. So then since the top one has x to the 2nd power, I'm going to give it an x to the 3rd power, and in order for it to be the same. So I'm going to go ahead and rewrite the x to the 2nd power, but I'm also going to give it an x to the 3rd power. Now the top one doesn't have a y to the 3rd, so I'm going to give it a y to the 3rd. The y to the 3rd here stays. And then for the top one, it has a z, but there's no z in the bottom one. So then the LCD for this one then becomes 3x to the 5th, y to the 3rd, z. So remember, you want to have exactly the same thing in both of them. So again, if I look at number 2, I'm not going to do this one. So if I look at number 2, I have a 5a to the 3rd power, I have a b squared. I have a 10a to the 4th, and I have a b. So what I'm going to do for this one is I'm going to give it a 2. I'm going to put a parentheses around it because I have a 10 here. Now I have an a to the 4th, so this one already has an a to the 3rd, so I'm going to give it another a. The top one has a b squared. This one already has a b, so I'm just going to go ahead and give it another b. And so if you look at it, the LCD will be 10, a to the 4th, b to the 2nd power. And now they have exactly the same. Here again, my top one is a difference of squared, right? So a squared minus 25 is going to be a minus 5, a plus 5. Now my other one, if I factor out a 2, I have an a minus 5. So then in the top one, I'm going to give it a 2, right? And in the bottom one, I'm going to give it an a plus 5. So then my LCD will be 2 times a minus 5, a plus 5, which I can write as 2 times a squared minus 25. This one, right, I have x squared minus 2x, and then here I have x squared minus 4x plus 4. So I'm going to factor out an x, and then this one is going to be x minus 2, x minus 2. So then you can see that the top one is missing an x minus 2, and the bottom one is missing an x. So then my LCD will be x times x minus 2, which I can write as x times x minus 2 to the 2nd power, or x times x squared minus 4x plus 4. All right, that's extra credit. I would explain that in the previous one. So let's go to the next one to have. So in this one, it says we're going to find the LCD of each pair of rational expressions, then convert each expression to an equivalent fraction where the denominator is equal to the LCD. And so what we're going to do is we're going to go ahead and see what we have. So, oops, sorry. So we have a 2ab. We have a 5a squared. And so we're going to see what we're missing. So in the top one, I have a 2 and a 5. So I want to give it a 5. And in the bottom one, I'm going to give it a 2. Now this one has an a squared. This one has an a, so I'm going to give it another a. And then the top one has a b, and the bottom one does not have a b, so it's going to get a b. So then my denominator is going to be 10a squared b. Now, what happens here, though, is in order for me to get there, what I'm going to have to do is I'm going to have to multiply each of the fractions by what I had to give it. So if you think about the 2a squared, 2ab, sorry, and I ended up with a 10a squared b, then what I'm going to multiply by is 5a. So 5a will give me my 10a squared b. So then I multiply the top one by 5a, and then I multiply also my denominator by 5a, which will give me 15a over my 10a squared b. Now I'm going to go ahead and get rid of this here so I can see it. Now for my 5a squared, what I did was I gave it a 2b. So then I'm going to give a 2b, right, times my 6 over 2b times 5a squared. So then this will be 12b over my 10a squared b. And then here, my LCD, this one's a little easier because my LCD is just going to be x plus 1, x minus 4. So then this one I have to multiply by x minus 4, and then x minus 4, x plus 1, right? And so the other one I'm going to multiply by x plus 1. So I have x plus 1, x minus 4, x plus 1. That doesn't matter how you fit them in there. Let me do this. X minus 4, do it again. So x plus 1. So those are equivalent expressions. If I were to cancel out the x plus 1 on the right, I'll end up with the original, which is 7 over x minus 4. So here again, right, I have an rs squared, and then I have an r to the third s. So for this one, I got to give it an s, right? So I can have the square, and in this one, I'm going to give it an r squared. And so my common denominator will be r to the third s squared, right? So then for this one, I'm going to multiply times r squared over r squared, rs squared. And in my other one, I'm going to multiply by s, so it's going to be negative s over s r to the third s. And then that'll give me my common denominator of r cubed s squared. All right, we'll skip this one, also this one. And then this one here says convert each expression to an equivalent expression with the dominant denominator equal to the LCD. So what happens is, if you remember, I did this previously, that this is equal to this, which means that 7 minus x over x minus 7 is equal to negative 1. So all I have to do is multiply the right one by negative 1, so then it becomes negative 1 x minus 7, and then they have the same denominator. So this one's a little easier than the other ones. So let's go ahead and see this one again. So it says convert, find the LCD. So the LCD for this one will be w minus 2. And so in order for me to convert that, I just multiply the second one, which will be this one right here, by negative 1. And then I get the negative 1 over w minus 2. And that's the end of 15.3.